In this video, we aim to understand the power associated with an AC circuit. So our goal here is to determine the power for any given circuit, whether it can be a purely resistive, capacitive, inductive component, or it can be any combination actually. So by understanding this, by exploring this, we can gain insight into the power characteristics of various configuration within a AC circuit. Okay guys. So basically it can be a purely resistive capacitor or resistance. I actually told that. It can be purely resistive, inductive or capacitance. And what is the power for that particular circuit? If someone asks, we can use this particular derivation or the final answer. Now, the derivation starts in this manner. Since it's AC, we'll be talking about instantaneous power and instantaneous voltage, and of course, instantaneous current. So let the voltage and current at any instance be given by I, which is equal to I naught sine omega t minus phi. So phi can be positive or negative for E, which is equal to E naught sine omega t. So for this particular source, the current can be leading or lagging. It depends on the phi value. Now, how do you talk about power? So we know that instantaneous power will be equal to I into E. As simple as that. So when you substitute, therefore, P will be equal to I naught, E naught, I'm just rearranging directly, sine omega t minus phi into sine omega t. And this looks like what expression? Sine A, sine B. And this is nothing but, try to recall, we have cos of A minus B minus cos of A plus B. There's something else missing. What is that? Yes, this entire thing divided by 2. So that's your formula. You guys remember? I hope you guys do. Now, when we apply it over here, we have I naught, E naught by 2 is there. And we have numerator. Cos of difference between those two will be phi, right? Yeah. Cos of minus theta is theta, so I don't have to think about negative sign. And here it will be cos of 2 omega t plus phi. Now, the very first derivation that we did in this chapter, that AC source averages out to 0 or an entire cycle. So what is that we are trying to do over here? We are trying to tell that cos 2 omega t plus phi, which is a function of time, averages to 0. So we can equate this to 0. And so your power expression will be I naught E naught by 2 cos phi. So this is your general expression. We'll be picking up the specific cases in the next video. So this is a very simple video. All you have to know is this particular formula. Sin A, sin B formula, if you guys know, you're pretty much done. Okay, there's one more thing actually I forgot to do. So this can also be expressed in the following manner. So another expression. We have P is equal to I naught by root 2, E naught by root 2. What are this? Cos phi. These are your, remember, RMS value. root mean square value. This is one more expression. And cos phi is also given by your r by z. You have to go back to another derivation. So this is another expression. Actually, another not set. I mean, we can derive few more, but yeah, this is another set of expression, and you can have more expressions.